Hello. In the last couple of videos we've touched on some useful constructs within C, one of them being arrays of pointers. Well, we've covered pointers as a generic tool before, but arrays of pointers are slightly different in that they are an array, and an array is just a lot of memory locations, such as this one here from 400 through to 406, which contains something. In this case I've represented it as the ASCII of hello, with followed by a space and followed by the null terminator. It might be useful to realise that that's not actually how it's seen in memory. It would be seen in memory as the hexadecimal or binary equivalent. And this is the ASCII table. So, for example, the small letter H is the hex of 68 and the decimal of 104. But rather than type all that in, because it makes it rather difficult to decode, I've just sort of written it like this, such that it's easier to see. The backslash followed by a 0, and that is a number 0, is a representation in C for the null character, which is the ASCII value of 0 there, and as you can see it says null. And that null is used quite a lot within the C code. It's used to determine the end of a string. So whenever you terminate a string, you'll hear sometimes it'll say null terminated string, and that's basically what it means, is stick a 0 in there. Now when we talk about 0, we're talking about the binary 0, because if we go back onto the ASCII table and we have a look, the number 0 is represented here, and it actually has a hex value of 30, or a decimal value of 48. And the same when you go 1, 2, 3, 4, 5, 6, 7, 8, 9. They've all got different values. So when we talk about the numbers, the representation of the number 0 in ASCII, what we're talking about is that ASCII value of 30. But when we're talking about the null character, we're actually talking about the number 0, i.e. the hex value 0 within here, and this is what this represents, this \0. That's what that represents in C. So whenever you write some C code, you know, if you want to represent the null character, you escape it with the backslash, and then you put the number 0 in, which basically says, actually I want you to represent this as the null. There is the word null, N-U-L-L, in capitals also. But that just is a sort of a static reference to that, you know, to the numbers, to the ASCII 0 within the ASCII table. Okay, so that rather convoluted explanation brings us on to arrays of pointers. And in C, you define an array of pointers such that you say this is a pointer, this is an array, and I'm of the pointers, and I'm of type character there, like that. So let's say the compiler decides to put our array at starting at address 200. If we have strings of characters defined in memory somewhere, we can point those at those strings of characters. So this particular, you know, we'll start with 400. So that's the first pointer there. So that points to the word hello, because it's null terminated. It's got a space in it as well, by the way. That representation there is a C representation. 0x is a C representation for hexadecimal, and 20 relates straight back here. And there you go. And it tells you it's actually the space character, as in a blank space. So this says hello space, how space, r space, u space, null terminated. But at the moment we've only got one pointer pointing to the hello. If we had another pointer pointing to 500, because that's where the compilers decided to put this particular string, then that would point to there. Now notice that 644 is not the next pointer. The next pointer is 908. Okay, now I did this on purpose because I wanted it to be obvious that you don't have, the way the compiler works is it doesn't actually need to be contiguous or in any kind of order in memory. It just allocates memory how it can and what comes next. So they don't always start on even boundaries. They can start in any order, and the pointers can point to them, anywhere you like, and it makes absolutely no difference. So you can actually simply turn this sequence back to front or inside out or anywhere you like, by rearranging those pointers. But that's how an array of pointers works. So what would happen is, if we go back to, no, not there, if we go back to this, if we have a look at the way that an array is, if we say, okay, so what's in that first array, what is it? So you look at array element 1, or sorry, array element 0, or array element 1, or array element 2. Well, they contain the addresses of the strings that we're pointing to here. So this is basically how an array of pointers works. Now, what I did, and I have to remember where I put it. I think I put it in here. So I actually created a very small program to demonstrate this. And what this does is it creates an element in memory and sets it up to, this is a character array. And it's effectively a string tokenizer like strtok. So when we were looking at strtok before, what strtok does is it takes a string that you type in, so the input buffer, and the input buffer points to this here. So in our case it was insert 0xC000 space A9 null terminate. But what strtok does is it comes along and it changes whatever we pass through to it as a delimiter. Now, we told it space was a delimiter, so what it would actually do, it would actually come along and it would change that, and it would change it to the null character, and then it would point this pointer to the first element there, and it would come down here and look for the next space. This is where I've got another one. So then it would change that to a null terminated character, like that, and it would point that one to this here, so to there, like that, and this one will point to there, like that. Okay, and then it would null terminate, and I haven't bothered putting the backslash in just because I wanted to point out that it is actually just a number 0. It would actually point the final thing as a null character, so it would actually say, I'm not actually a pointer, I'm just nothing. So you've got a null terminated array of pointers pointing to each part of this contiguous array. So this input buffer now, if you were to print input buffer out once it had finished, you would actually only get the letter I, because this here is a null terminated string, and printf will only print up to and including a null terminated string. So in our in my example here, in what I wrote here, very, very simple, it says this is a character array and it's null terminated. I've created some pointers, so that's a standard pointer, that's a double pointer. It doesn't have to be, but I thought we'd tie all the pointer stuff together in one go. This is a pointer array of pointers, rather. I've created it as size 10. It doesn't have to be, because there's only 1, 2, 3, 4, 5 5 values in there. So the first thing it does is this is the contents of P, so it prints P, and because you're printing the contents, what you're actually going to print is, because P is pointing to the beginning of array, you're going to print a whole lot of that, because printf will print up until a null. And this is the contents of double P, and double P points to the address of P, so it's going to print that again. And then what we've got here is we set the first, so K is predefined as 0, so is J, and so is T. We don't actually use T, but J and K are set to 0, so it sets the value of the first element, the 0th element, to point to the beginning of the array, and then increments k, so k now equals 1. It then goes around this loop up until the array element is null, so it will go all the way through until it sees the null, incrementing j, so it says this THIS, it goes round and round and round, and it says if the array j is equal to space. Well, the first time round it isn't, second time round it isn't, no it isn't, no it isn't, now it is. So what it then does is it says array, so array j plus plus now equals that. So what it says is array, the jth element of the array, i.e. this that we're looking at, the space, we'll set it to a null, which is exactly what that does there. So sets it to a null, and then increment j, so we can go around. Then increment j, so we can go around again. But at the same time, I want to set the token to point to the next element along in the array. So because k is already equal to 1, so token 1 equals whatever the array plus j, whatever j plus 1 plus array is, alright, which is that I. So what will happen is it'll come along and it'll say token k, which is the first, which is element 1, so the second element in the array, will point to the I of array j, right, because we've already incremented the j there, right. It'll then go round again and it'll say I isn't a space, that S isn't a space, that is a space, and it'll do exactly the same thing again. And then it'll do A isn't a space, but that is a space, do again, so k will now equal, what will it equal, 0, 1, 2, it'll now equal 2, so that'll be 3 there. And it'll go through character, do the same, hit the space, change it to a null terminate, and then it'll go through the array, hit the null terminate, and the null terminate's the precondition for the for loop. It'll drop out, so it'll say, well actually this token now set it to null, which is what strtok does here, look. And then we just go round and we print it. So if we make that, can I do that? Array pointer, oh there we go, pointer.c, so there we go, so we make that, and then I think it's just ./a.out because we haven't done anything else with it. So there you go. So what happens is it comes along and it says the contents of the of P is this is a character array, which is exactly what we expected it to print. The contents of double pointer is this is a character array, because that double pointer is pointing to the address of P, and therefore when you reference it, you're referencing a double pointer here. Look, don't forget we dereferenced the double pointer, so therefore we're actually referencing what P is pointing to. We covered that in one of the previous videos. Then we do this entire loop structure with the check condition, and then you end up with this is a character array with a null terminate at the end. And that is kind of how strtok works. It's not perfectly exactly how it works, but it gives you an idea of how you split up, or how you can split up an array of characters into various tokens. And you can tokenize with strtoks a lot more powerful than this, because you can tokenize on all sorts of things, you know, on curly braces or on whatever, and we could, you know, if we wanted to, we could change that to find other delimiters if we wanted to, rather than the space character, you know. I mean, we could fiddle with that any way we like, and maybe we will. Maybe we'll just add a little bit of an example here. So if we wanted, for example, instead of making that the null, instead of making this the space, if we wanted to say, let's make this interesting. Let's get rid of all the I's. Okay, and then we can compile that, and then we can run that, and it does all this really weird thing. But if you actually work that out, it's exactly right, because what it's done is it's broke it on I's. So this is a character array, so the contents of P, right, so is this, so there's the first I on the A, so the A is gone, alright. There's no I on is. Alright, and then the rest of it is character array. So it's done it. It's not perfect, but you get the idea. And this is what we're talking about when we talk about arrays of pointers. So basically the array of pointers looks like this, where you point to various bits of memory. You can use them to, within strtok, and an array of pointers can point to what was previously a single string, but then it gets broken up, as we've just seen, and you can use an array of pointers to point to the various elements of that. So input buffer now is the user ornament, as far as we're concerned. So that is the last thing to note, really, is that strtok or strtok will break. It's destructive in the fact that it changes your input string, and therefore your input string is no longer useful. If you wanted to maintain that input string, you'd have to copy the string to somewhere else, because it will destroy the original content. So that's basically it for this one. It was just sort of a quick overview to see what this stuff looks like in memory, and how it kind of works, because when we come on, we'll be using more and more and more of the pointer stuff. I've tried to keep it to a minimum because it is quite a complicated subject, especially when you start to try and dereference and you've got all this kind of weird parentheses and things around everything, and it starts to look like a great big convoluted maths formula. At that point you think, oh, this is really difficult, but there are times, and you'll see this, I started to use it later on because I started to think, well, actually, the way that pointers work makes the coding so much more straightforward, especially when you're dealing with the array, and you need to write to memory and you need to compare memory and things like that. So it's actually quite a lot more straightforward to use pointers than it is to try and pass variables backwards and forwards.